Welcome to HP Tuners Subaru Training Part 23. In this training tutorial, we're going to be focusing on working with our spark tuning and programming, as well as looking at the knock control and how it functions within the Subaru ECU. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our spark tuning and our knock control programming within our Subaru ECUs. We have to understand the flow of logic and where spark timing comes from in terms of all the different tables and how they fit together, so that when we're calibrating and tuning our spark timing, we know exactly what's going on and we know how to interpret log data to be able to come back in and make appropriate and safe changes to our spark timing tables. So we're going to break down everything in this tutorial. In our previous tutorial, we looked at spark timing in general terms, just making sure we understood the values in the table and what they represented and how it worked within the auto cycle. So you'll have that as a frame of reference moving into this tutorial, and things will make a lot more sense. Let's jump in here and take a look and talk about how our spark timing is calculated first, because we have our spark timing and then we also have our knock control, and they fit together and they ultimately deliver a certain amount of spark timing to the engine to make good power and to keep the engine safe. But again, we need to understand this flow of logic, where the ECU is calculating everything from, so we know when we're looking at the information in some data logs, what to actually do and what to change. So the first thing we have, and let's go in again, we're looking at our spark timing here first. The first thing we need to consider is going to be the base spark timing table. The base spark timing table is where the spark timing is going to be starting from. So we're going to go into the table here, taking a look. We see that it's based on engine load on one axis and engine RPM on the other. Now, engine load is a function of air mass, measured from our MAF sensor or estimated from our VE table for speed density mode. It's going to be the air mass multiplied by 60 divided by RPM. That's how we get the value within the table. So we'll find, for perspective's sake, looking at the table here, 0.3 to about 1.1. That's going to be the range where we're going to have idle and part throttle driving. 1.1 going into 1.3, that's where we start to transition into some boost, maybe about 3-4 pounds of boost. That's going to be that transition between vacuum and boost. Now, looking in the values of the table, we find that they do vary around. So as the engine speed goes up, the values get higher. As load goes up, the values get lower. Again, we talked about why the table is like this in the last tutorial. I don't want to go into those specifics right now. The values in the table are going to be where we want to fire off the spark plug in degrees before top dead center on our compression stroke. And the values in the table aren't arbitrary, they're very specific, so that we do have our peak cylinder pressure reaching the piston on our power stroke. So when the piston's moving downwards on the next stroke, around 15 to 20 degrees after top dead center. That's going to be timing that point and having that best mechanical advantage of pushing the piston and rod assembly down to spin the crankshaft to produce the horsepower and torque out of our engine. So the values in the table are going to be very specific. They're there for us to be able to have a starting point to be able to start calculating our spark timing, where we want to go and command that spark event to happen to start our combustion process. Now, this is just going to be the start. We do have a couple other things to consider to figure out our total timing. So the total timing is what we ultimately want to deliver to the engine. So total timing, the equation would be total timing is equal to base or space spark timing plus the ignition advance multiplier table values. We'll talk about that here in just a second. And then the timing compensations. So it needs to go through all of this. This is going to be a cumulative type of equation, meaning they all have to add together to ultimately deliver a certain amount of spark timing. So we may find that we have a timing compensation table that might be taking away timing, and we'll find that reduces the total timing that we would deliver. So the total timing at any given load and RPM point is going to be ultimately what we want to send to the engine for the spark plug to fire at in order to create that combustion event and have our pressure pushing down on the piston at that optimized point. Now, we may not reach the optimized point. That's part of the calibration process of actually moving the values around in the table, trying to figure out and trying to get to maximum brake torque timing. But what we'll find here is that we have to go in and add all of these together to ultimately figure out what that total timing value should be at any given load and RPM point. Now, the ignition advance multiplier here, that's the next portion of our total timing equation. The ignition advance multiplier is a function of the knock control. We'll talk about that in just a few minutes, but what we'll find is we have tables, there are actually 4 total tables for ignition advance multiplier. We're going to be using primarily 2 tables and actually primarily 1 table under full throttle conditions, kind of whittles away the tables. Again, we'll talk about what each table represents a little bit later. But the ignition advance multiplier We'll look up what the engine speed's going to be at and look up what the engine load's at and add timing to our base timing amount. We'll find that the spark timing is going to be a dynamic type of system in conjunction with the knock control, and the ignition advance multiplier ties together our base spark timing into the knock control routine, allows us to have this dynamic moving spark timing based on what the engine is doing in terms of knock. Again, we're not going to get into that at this moment, but understand that the base spark timing plus the ignition advance multiplier would give us portion of the total timing. Now we need to go through the timing compensations. The timing compensations will be accounting for things like intake air temperature, engine coolant temperature, gear position we're at, and individual cylinders, if we're having knock in individual cylinders. Let's talk about our timing compensations here real quick. Looking at our intake air temperature, on the table here, we're going to find the left axis is going to be air temp, and then the right axis is going to be either adding or subtracting timing based on our... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.